In this video, I'll be discussing the intercept form of quadratic functions. So previously we had talked about standard form, which is y equals ax squared plus bx plus c, and what pieces of information you could grab from that, as well as your vertex form, and what pieces of information you could find from that form. So if a quadratic function happens to be written in y equals a times the quantity x minus p times the quantity x minus q, which is called intercept form, then you can find two x-intercepts, which are also referred to as your zeros. And we talked about why they're referred to as your zeros in class, as well as your axis of symmetry. And if you can find your axis of symmetry, you can find your vertex. And then for additional points, you can always use substitution and a t-chart. So I'm going to work out a couple of examples. The first example, f of x equals x plus 3 times x minus 3. So first and foremost, I'm going to write out my two zeros, and that from this one, this is going to be negative 3 comma 0, and this one is going to be a positive 3 comma 0. And so I can go ahead and actually graph those two. So negative 3, 0 and a positive 3, 0. And we talked that in class, your axis of symmetry is going to be directly in the middle. Here it's really easy to see what it is. But what you do is you take your p and your q, you add them together, and you divide by 2. You're averaging those values because you want the middle. So that's 0 over 2, which is 0. So x equals 0 is your axis of symmetry. So I'm going to draw that on my graph. And then we talked about how to find your vertex. If you have your axis of symmetry, you simply use substitution and find f of 0. So you replace x, 0 plus 3, times 0 minus 3 equals a positive 3 times a negative 3, which is negative 9. So your vertex is at 0 comma negative 9. So I can go ahead and graph that. 0, negative 9, 2, 4, 6, 8, 9. Yeah. Alright, so if I just leave that graph the way it is and connect the dots, it's not going to be as accurate. I do want some points down here that are going to be closer to my vertex. So we're going to go back to our original equation and use a t-chart. We can also notice here that our a value is equal to 1, which means it's positive and should open upwards. So I'm now going to create a t-chart, x, y. My vertex should be in the middle with a 0, negative 9. So I'm going to plug in some values on the right side, 1, 2, 3, and then I'll reflect those for values on the left. So f of 1, that comes out to 1 plus 3, and 1 minus 3, which is 4 times negative 2, negative 8. And then f of 2 is equal to 2 plus 3 times 2 minus 3, which is 5 times a negative 1, which is negative 5. Alright, and that should be enough, 5 points on each side to get a pretty good picture. Alright, so I go to 1, negative 8, and then I go to 3, negative 5. Alright, we're going to have an excellent picture here, because we've got a total of 7 points. Alright, and our a was positive. It was a positive 1, so it should open upwards, and it does. Alright, we're going to look at another example here where there is another a value. Alright, so first and foremost, I want to go ahead and find my x-intercepts. And this one's going to give me a positive 5, 0. And this one is going to be a negative 1, 0. So I want to plot those 2 points. 5, 0, and a negative 1, 0. So I know my my x-intercepts. If I average those values, that will give me my axis of symmetry. X equals 5 plus a negative 1 over 2. So that's 4 over 2. So my axis of symmetry is at x equals 2. So I know that my vertex falls on this line somewhere. And this is where I want to do some double checking here. I'm going to look at my a value. A is equal to 2, so it's positive, which means it opens up. Alright, it's always helpful to know which way your graph should be facing. So I'm going to go ahead and substitute my axis of symmetry back in to find, so g of 2 times 2 minus 5 times 2 plus 1. So that comes out to 2 times negative 3 times 3. And that's going to be a grand total of negative 18, which is definitely off of this graph. It's going to be just about double down here, so I'm going to have a pretty badly drawn picture. I apologize for that. So in that case, I want to go ahead and make a t-chart because I'm going to need some other points to make this graph look good. Alright, so my vertex is at 2, negative 18. So that's the middle of my graph. So I want some points on the left and right. So I want to go 1, 0, and then 3, 4. Alright, so I'm going to find g of 1. G of 1 equals 2 times 1 minus 5. Remember, I'm replacing x. When I find g of x and I'm looking for a g of 1, I'm replacing x with 1. Alright, and this becomes 1 plus 1. So that's 2 times negative 4 times 2, which comes out to a negative 16. And that's going to be reflected for 3, so that's still way off my graph. Right, that's barely above it. I'm approximating here. Let's find g of 0. Maybe this one's on my graph. 2 times 0 minus 5 times 0 plus 1. So that's 2 times negative 5 times 1. Yeah, negative 10. Alright, so 0 and 4. 0, negative 10. And 4, negative 10. Alright, these ones are the piece of my parabola that are on my graph. Alright. Normally when you guys are given homework and you have to hand draw your graphs, if you have to hand draw your graphs, you would probably want to draw it to where the majority of your graph is in this fourth quadrant. And when you're given homework worksheets, most of your graphs are adjusted so that you can fit them on there. So in addition to the last video that I had on vertex form, I'm going to be posting another video of how to use vertex and intercept form and how to get it back into standard form using our foiling method so that you can use the tricks we used before.